Alright, so in this problem, I have 4 to the power of x is equal to 40. So to solve this, I'm going to first start by taking the log on both sides. So now I have log 4 to the power of x is equal to log 40. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is equal to b times log a. So in this case, I have log 4 to the power of x, so I can move x to the front. So now I have x times log 4 is equal to log 40. Now, I'm going to go ahead and divide both sides by log 4. So then these two cancel out, and now I have x is equal to log of 40 over log 4. Now, log 40, this is the same thing as log of 4 times 10. Because log 40 is equal to 4 times 10. So I have this over log 4. And now if I have something in the form log a times b, this is equal to log a plus log b. So in this case, I have log 4 times 10, so this is equal to log 4 plus log 10, and now I have this over log 4. Now log 4 plus log 10 over log 4, this is the same thing as log 4 over log 4 plus log 10 over log 4. And log 4 and log 4, these two cancel out, so now I have x is equal to 1 plus log 10 over log 4. So now log 10, this is the same thing as 1. Log 10 is equal to 1. So now I have x is equal to 1 plus 1 over log 4. And log 4 is equal to 0.602, so now I have x is equal to 1 plus 1 over 0.602, which is equal to 1 plus 1.66, meaning x is equal to 2.66. Alright, so in this problem, I have x to the power of x to the power of 4 is equal to 64. So I need to find the value of x here. So for my solution, I'm going to first start by taking the power of 4 on both sides. So now I have x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can switch the places of m and n here. So in this case, we can think of x to the power of 4 here as m and 4 as n. So if I switch the places of these two, I get x to the power of 4 to the power of x to the power of 4 is equal to 64 to the power of 4. Now I'm going to replace 64 with 8 squared. So now I have x to the power of 4 to the power of x to the power of 4 is equal to 8 squared to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So a to the power of 2 to the power of 4, that's going to equal a to the power of 2 times 4, which is equal to a to the power of 8. So I have x to the power of 4 to the power of x to the power of 4 is equal to a to the power of 8. Now I'm going to let x to the power of 4 equal to the variable y. So now I have y to the power of y is equal to 8 to the power of 8. And if I have something form a to the power of a is equal to b to the power of b, this means that a is equal to b, meaning y is equal to 8. Now remember how we let x to the power of 4 equals y. So if x to the power of 4 equals y and y equals 8, then this means that x to the power of 4 is equal to 8. So now to solve this equation, I'm going to take the fourth root on both sides. So the fourth root of x to the power of 4 is x, and so I have x is equal to fourth root of 8. So now to check, my original equation was x to the power of x to the power of 4 is equal to 64. X is equal to the fourth root of 8, so now I have fourth root of 8 to the power of fourth root of 8 to the power of 4 is equal to 64. Now the fourth root of 8 to the power of 4 is simply 8. So now I have fourth root of 8 to the power of 8 is equal to 64. Now this is the same thing as 8 to the power of 8 over 4 is equal to 64, meaning 8 to the power of 2 is equal to 64, and 64 equals 64. So this is right. Alright, so in this problem, I have x to the power of 3 plus x is equal to 10. So to solve this, I'm going to first start by subtracting 10 on both sides. So now I have x to the power of 3 plus x minus 10 is equal to 0. Now negative 10, that's the same thing as negative 8 minus 2. So now I'm going to switch the order of these and rewrite this as x to the power of 3 minus 8 plus x minus 2 is equal to 0. So now 8 is the same thing as 2 to the power of 3. So now I have x to the power of 3 minus 2 to the power of 3 plus x minus 2 is equal to 0. Now if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, x to the power of 3 minus, x to the power of 3 minus 2 to the power of 3, I can rewrite as x minus 2 times x squared plus 2x plus 2 squared, which is 4, plus x minus 2 is equal to 0. So now if I factor out x minus 2, I get x minus 2 times x squared plus 2x plus 4 plus 1 is equal to 0, which is the same thing as x minus 2 times x squared plus 2x plus 5 is equal to 0. So now to solve this, I have two equations. I get x minus 2 is equal to 0, and x squared plus 2x plus 5 is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2, so this is one solution. And for x squared plus 2x plus 5 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, b is equal to 2, so I have negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 5, all over 2a, so 2. Now this is the same thing as negative 2 plus or minus the square root of 4 minus 20 over 2, which is equal to negative 2 plus or minus the square root of negative 16 over 2. Now the square root of negative 16 is the same thing as the square root of 16 times the square root of negative 1, and the square root of negative 1 is equal to imaginary number I. So negative 2 plus or minus the square root of, square root of 16, which is 4, times I. I is the square root of negative 1 over 2, which is equal to negative 1 plus or minus the square root of 2i. So two more solutions. Alright, so in this problem, I have 8 to the power of x plus 2 to the power of x is equal to 68. So I'm going to first start by rewriting 8 as 2 to the power of 3. So I get 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 68. Now I'm going to rewrite 2 to the power of 3 to the power of x as 2 to the power of x to the power of 3. So I have this plus 2 to the power of x is equal to 68, and I can do this because if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. Now from here, I'm going to let 2 to the power of x equal to the variable y. So if I substitute in y for 2 to the power of x, I get y to the power of 3 plus y is equal to 68. Now I can subtract 68 on both sides. So I get y to the power of 3 plus y minus 68 is equal to 0. Now, to actually factor this and find the value of y, I need to first find the factors of 68. So the factors of 68 are 1, 2, 4, 34, and 68. So now 1 wouldn't work because 1 times 68, we can't subtract those two to get y. And 2 wouldn't work either. The only one that would work is 4, because if you divide y minus 4 with y to the power of 3 plus y minus 68, that would be factorable. So now that we know that 4 is a proper factor, for my original equation here, y to the power of 3, I'm going to rewrite this as y to the power of 3 minus 4y squared plus 4y squared minus 16y, which is 4 squared, plus 17y, because negative 16y plus 17y is equal to y, and finally minus 68 at the end is equal to 0. Now I'm going to factor by grouping. So these two are a group, these two are a group, and these two are a group. From y to the power of 3 minus 4y squared, I'm going to factor out y squared because that's the greatest common factor. So I get y squared times y minus 4 plus, from 4y squared minus 16y, I'm going to factor out 4y, so I get 4y times y minus 4. And from 17y minus 68, I'm going to factor out 17, so I get 17 times y minus 4 is equal to 0. Now if I factor out y minus 4, I get y minus 4 times y squared plus 4y plus 17 is equal to 0. And now this gives me two equations. I get y minus 4 is equal to 0, and I get y squared plus 4y plus 17 is equal to 0. So for y minus 4 equals 0, add 4 on both sides, and I get y equals 4. For y squared plus 4y plus 17 equals 0, I can factor this by using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. So in this case, a is 1, b is 4, and c is 17. So I get y is equal to negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times 1 times 17, all over 2a, so 2 times 1. This is equal to negative 4 plus or minus the square root of 16 minus 68 over 2, which is equal to negative 4 plus or minus the square root of negative 52 over 2. And this is equal to negative 4 plus or minus the square root of 52 times the square root of negative 1 over 2. And the square root of 52, this can be simplified to, well, 52, that's 13 times 4, and 4 is 2 times 2, so this can be 2 root 13. So I get y is equal to negative 4 plus or minus 2 root 13 times the square root of negative 1, which is simply equal to I, over 2. Now if I divide both terms by 2, I get y equals negative 4 plus or minus the square root of 13i. Or sorry, negative 2 plus or minus the square root of 13i. So now that we know these values of y, remember how we let 2 to the power of x equal to y, meaning I get 2 to the power of x equals 4, and this is obvious, x equals 2, so that's one solution of x, and I also get 2 to the power of x is equal to negative 2 plus the square root of 13i, and 2 to the power of x is equal to negative 2 minus the square root of 13i. Well, 2 to the power of x, we can't take the power of a positive number and make it equal a negative number. So there's no solutions for these two, and x equals 2 is my only solution to this problem.